And the presenters are Dave Foster and Dave Hall. It's up.
Okay. Trying to accomplish two things with this talk, and Dave and then Aaron will follow me. One is to just highlight one of the synthesis activities that we're engaged in, and the second is to provide an update and continued invitation to you all to engage in some long-term studies and experiments that are going on with Hemlock. One of the fascinating things about the Harvard forest is that essentially from the first year that it was established by Richard Fisher, whose memorial plaque is shown here, which is sitting out in the woods, there's been a fascination with Hemlock. And Hemlock, as we all know, is at a kind of poignant place in its recent history. It's sitting in the woods and either dead from the woolly adelgid or infested by the woolly adelgid or waiting in trepidation for the woolly adelgid to arrive. And so we thought that one of the interesting exercises that we could undertake would be to synthesize all of the LTR research and then to go back and integrate all of the other Harvard Forest research on Hemlock and produce a volume as part of the LTR series, which is on Hemlock. And to just give a bit of a flavor for some of the range of studies that are out there. They range from Richard Fisher, who described the early hemlock stands here and actually identified that stand that's in that largest diorama as his favorite spot on the Harvard forest, which is why he's pictured in that diagram. But he went on to cherish these old stands because they represented the forest that had been driven by natural process the longest. And he sought those kinds of stands out because he was interested in learning from natural dynamics in order to bring those lessons into the silviculture that he was trying to apply as a new forester and a new educator in forestry at the Harvard forest. And so among other things, he's the individual who, if not found, certainly recognized the value of the Pisgah forest and a series of other forests up in southern New Hampshire. And then he led the national effort to conserve that forest, which was an old growth forest, and was responsible for leading all of the studies that led to an understanding of how that forest operated through natural growth and dynamics as a result of disturbance, which is what he then applied to his interpretation of the pre-settlement landscape, which is displayed here and described in the diorama booklet. Another thing he did was he sought out students to work on Hemlock, and so down here we have a picture of Bob Marshall, who went on to found the Wilderness Society. Bob Marshall is not working in wilderness, and he actually turned down Richard Fisher's invitation to go to Pisgah and to reconstruct the history of that forest. Because Bob Marshall was so passionate about wilderness that he felt he needed to become the absolute best forester he could to learn himself and to be part of the process to learn how to manage woods very well, so that that would take some of the pressure off of vast landscapes around the United States that could be set aside as reserves. So in his high school days, he vowed to become a forester, and here he is working at the Harvard Forest, getting his master's degree on a plot that was one of the earliest and largest experimental manipulations at the Harvard Forest. It was a series of parallel treatments of different silviculture on hemlock forest, in which he predicted how those forests would develop based on his reconstruction of that forest before it was cut down. So Bob Marshall is not only an interesting figure historically, he figures in critically into the Harvard Forest because he's the individual who developed our historical approach for reconstructing forests. But there are a whole range of other studies. There's all Dave Orwig studies on the adelgid, the way that the trees are dying. There are studies by us out in the middle of the Prospect Hill Tract, which is this forest here, where we have a tower, and it's part of the headwaters of a couple of the streams that we look at. There's Julian Hadley's work on the actual ecophysiology of the species, as well as kind of the integrated flux measurements and so on. There's a range of other studies, insect collections, and other things that are going on in Hemlock Forest. If you actually look across the entire range of studies at the Harvard Forest, they're almost comprehensive, looking at almost everything one might want to know about that species and the kinds of forests, going back to reconstructing the history of the species coming in 8 to 10,000 years ago. And there's, of course, a notable study. This is a picture of the Pisgah Forest today. It blew down in the 1938 hurricane. A successor to Fisher withstood the public outcry that that forest be salvaged for its timber value and to reduce the likelihood of fire. And as a consequence, it's a fabulous laboratory of regrowth and development after a natural disturbance in what was a virgin forest. So taking all that together, we're putting together this volume. The volume will be finished by the end of this year, and it will then, the manuscript will go on and be published by Yale University Press. And I'm highlighting this both so that you can understand some of the synthesis work we're doing, but I'm also letting you know what the kind of range of topics are that we're covering, so that if you have interesting data or anecdotes or photographs or studies that relate to the Harvard Forest that deal with hemlock that you think aren't going to be captured by some of these individuals or the topics we've got here, we'd love to hear about it. But the organization of this book is going to be written in a very accessible fashion. It's going to have lots of illustrations, lots of photographs in it, and it's going to be written without embedded citations and lengthy footnotes. Each of the chapters will have a bibliographic essay for it. But we're going to have a little bit on kind of the species itself and wrapping that into one of the driving kind of paradigms or models that we use here at the Harvard Forest now, which is this idea of a foundation species that controls its environment and very strongly shapes the microenvironment and the dynamics of the forest that it lives in. Then a little bit about what motivates this study based on all this work that's going on in the past and where we are now in the history of hemlock. Then we're going to have kind of background to the study of hemlock and our understanding of hemlock, which goes from paleoecology and all the work that Wyatt and Wyatt and my predecessors in paleoecology have done here, including the witness tree data that Jonathan Thompson has pulled together, all of Tony D'Amato's insights into old growth forests and second growth forests and dynamics for hemlock. And then I'm going to write a chapter which is actually going to be kind of vignettes of these classic studies by Bob Marshall, by Earl Stevens, by Richard Fisher, by Stephen Spur, and so on, including the tannery, John Sanderson's farm. You know, John Sanderson was a tanner. He kept a woodlot which had hemlock in it so he could harvest it, take the bark from the tannery, grind up the bark in the stream down there, and then use that to tan hide. We're going to have a series of investigations which represent kind of the core of our LTER studies and approaches to understanding hemlock. We basically are using 4 or more approaches. One is just the natural experiment, long-term measurements across the landscape from Long Island Sound to Vermont, looking at the dynamics of these stands with and without the adelgid. Then we have an experimental approach in which we manipulate forest, and we'll hear a little bit more about those to simulate the kinds of impacts of the adelgid and control for other factors. We have the kind of long-term retrospective studies in which we're looking at the Hemlock decline and using that as an analog for the interaction of climate change and maybe the outbreak of an insect pest driving a millennium-long or multi-millennium-long decline in hemlock. And then we have a chapter that's on modeling, what that can bring into our understanding of current dynamics and future dynamics of the species. And then finally, we'll revisit the foundation species concept and what we've learned from the various studies, and we'll look very much at what has been learned here at the Harvard Forest and more broadly about conservation and the response to the kinds of disturbance that nature and introduced pests and pathogens bring to this species. So in sum, we hope to kind of cover a gamut of topics and a range of our understanding on hemlock, and rather than look broadly across the entire range of the species, we're going to focus really in on a New England landscape that has been very thoroughly studied by a range of people here at the Harvard Forest. And with that, I'm going to pass this on to Dave Orwig, who's going to talk about long-term studies that deal with hemlock and other species in the 35-hectare plot.
Thank you very much. I'm going to spend 1 minute going back to hemlock just for a second, because it made me think of a really poignant point from Dr. Fisher early on. And about 12 years ago, I was doing work on old-growth forests on Wachusett Mountain. And fortunately for that reservation at the time, they had early superintendent's notes from the early 1900s. It was 1901 to 1910. And right after the time they set up that reservation, they had Dr. Fisher survey the lands to look for interesting pieces of forest, and he noted one such piece of what he viewed as old hemlock, old hemlocks above this place called Echo Lake. And at that time, there was not much recognized old-growth forest, even in the 90s, and so it seemed logical to go see if that forest patch was still there, and it turned out it was. And that's one of the old-growth hemlock patches that we have since documented on Wachusett Mountain. It was directly related to Dr. Fisher, who did some work for the state early on in that century. And it was great to see that using these old records could actually lead to something still kind of new and undiscovered even in today's day and age. So just a little anecdote related to hemlock and, the first director here. So 2 years ago, I stood up here and talked about what the exciting proposition was. We'd start a very large forest dynamics plot here at Harvard Forest, and I'm going to give just a very brief update today, and hopefully next year, if time permits, I can give you a lot more of the data and the information that comes from this effort. As David mentioned this morning, Harvard Forest is one of at least 35 plots worldwide, both in temperate and tropical areas, all united by a very standardized methodology where every woody stem, at least 1 centimeter at DBH, is tagged, mapped, and measured. And so the Harvard Forest, which we now call a HF-side geoplot, the original soil warming plot, the 30 by 30 meter plot, was called the megaplot. So we don't call it megaplot anymore to avoid confusion. We now call it the HF-side geoplot, the Smithsonian Institute Global Earth Observatory, what that stands for. And we've talked about it a few times today, but it's located on Prospect Hill. Its dimensions are 700 by 500 meters. And as David pointed out, we set up this orientation so we could capture as much infrastructure as we could, including the Hemlock Tower. Which one is the EMS tower and its footprint. This is the walk-up tower, which will soon also be a neon tower as well nearby there. And also lower portions of the Greenwich watershed. As much as we could gather within that plot, we felt it was best to do so. Back in, I think it was the early 90s, there was a 100 by 100 meter grid set up across Prospect Hill, and we have since had professional surveyors come in and denote every 20 meters. If you ever worked in the 20 by 20 meter plot, this says 875 of them. So that's what these workers work on a day-to-day basis. Okay, so just to give you a brief history, in January 2010, we did receive word that we would get some initial funding to start the project. And we had surveyors come in that March and survey out very painstakingly the 20 by 20, and I might also point out 10 by 10 meter posts as well to get that ready to go. And then in June of that year, we began the census. We had 6 individuals that worked that summer that tallied and mapped about 34,000 stems. Last June, we had 10 hardy souls that helped us again for the summer, and they tallied an additional 43,000 stems, and at that point, we completed 32 of the 35 hectares. If we go back, one area we haven't completed is this area here, the beaver swamp area. And we did wait till this winter to try to continue to sample that. And I've only had 3 hardy souls that were able to do it over the winter time. They actually came in out of the field today. They're in the back, so I'll point them out later. But they were able to continue on and do another 5,000 stems under wintertime conditions, although this winter, not as much. We were hoping to have, ice for quite some time. The wind sank through. It didn't always happen. But we're up to about 82,000 stems right now. Almost 33 of the 35 hectares are complete. The goal is to finish it as soon as we possibly can, with the idea now that I think that we would set to do a recensus in 2016. And of course the highlight will then be able to use all this really interesting data. Here's an example of the type of information you can get. This is just the western third of the plot, and since this time slot is based on hemlock, the blue in this case is hemlock. So individual hemlock stems, spatially explicit, you can then size it by tree size. We have this one really dense patch of laurel in the northwestern portion, and in this case we also denote red maple. And of course eventually we'll be able to do this for the whole 35 hectare by species, et cetera, et cetera. So that'll be very exciting. I hope we'll share some of that with you next year. Just to give you just some flavor, again, the western third is certainly dominated by, in some cases, quite old hemlock. Whoops, sorry about that. In some cases, not real high densities, really large trees, sometimes up to 200-year-old hemlocks. And then everything else in between. We have this very, young forest in the south of that beaver swamp area. There's really young, dense stems. Over towards the eastern edge of the plot near the EMS tower, much more open, oak-dominated forest. We have a little bit of everything in between then as well. So it's going to be very interesting to look at those spatial patterns, the associations with other tree species, etc., and the type of data we can get from that. And these are just a few pictures of this beaver swamp. So if anyone would like to sample, let me know. It's not an easy task, and it's so much so that we're getting densities up to 900 stems per 20 by 20 meter plot. So that's in some cases 9 times more dense than these ultimate forested situations. Now, I know it may not be that different in some of these tropical areas that Stuart's been in, but for around here it's pretty dense. So every stem is painted and tagged and mapped. So it's taken us a little longer to finish than I had originally anticipated. I thought I would just mention a few new activities in case people may not be familiar with, and this is not an exhaustive list. These are just things that I thought of off the top of my head that are new and related to at least the hemlock portion or other portion of this large plot. Brian Enquist and many others had a macro systems proposal funded that takes place mostly in the hemlock area, but other parts of the plot. We're looking at overall the effects of temperature on biodiversity patterns. And Harbor Forest is one of, I think, 8 sites that they've looked at. And they're focusing on tree and litter invertebrates and soil microbes as well. So they've had 1 year and many more to come with that. And they have certain areas that they've denoted separately from ours, and they use different tags and everything so we don't get confused on the marking. Sean McMahon, who's a relatively newcomer to SciGeo as a temperate forest ecologist. He was able to use some of Bill Munger's dendrometer banded trees and was able to look at that bi-weekly throughout last growing season to look at the variation within the growing season. And then you know Adrian, but Adrian and his grandson Pollyanna Lemos are doing a really interesting study looking at soil carbon as hemlock is replaced by hardwoods. They're looking at a time series of sites. And so Harvard Forest, and mostly in that old section of the Harvard Forest site geoplot, they've chosen to look at soil carbon in an old maturing hemlock forest. And there's many other much other new activity, but these are just some of the three that I could think of right off the top of my head. And you know, one thing that we're going to be careful of is trying to be strategic in terms of, you know, we can't have 100 new studies going on in this plot. And so we need to be careful about what really doesn't make sense to do out there, and it's still consistent with all the other things with neon and everything else. And you know, so we want to be very careful in how we plan that out. And that's something to think about in the future as well. Some proposed activity that I know that we're planning on doing, or others are planning on doing. Some is dependent on funding and some isn't. We're just going to do it anyway. With the advent of hemlock woolly adelgid now within a decent portion of that plot, I mean, I'm certainly convinced that litter fall timing and quantities will change perhaps pretty quickly. And so starting this year, I want to increase the frequency of the collections up to 4 times a year versus the 2 times that we've been doing it. I'm actually going to, pretty soon now that adelgid should be in full swing here, do a survey of the entire plot, at least on a 20 by 20 meter basis, just presence absence for now. We may go into more detailed sampling in the future. You know, Bill, as I mentioned, has a lot of dendrometer banded trees in the eastern and central part of the plot and a few in the west. And Julian Hadley has quite a few trees that he looked at in the western part with the hemlock-dominated forest. But I think it might be nice to actually increase the number that are in the hemlock portion. So that's a goal that we have, and hopefully we can do that with increased funding. And there's also a proposal out there to try to also maybe increase the amount of soil respiration that's done in the hemlock forest. I know a lot was done prior by Julian and others, and so we think there still may be a gap there, especially as adelgid is there. It could change things, and we hope to do that soon. For hemispherical photographs, we certainly want to start that this year, because again, say it is a really warm or dry summer, things could change pretty quickly with adelgid. Aaron Ellison and others developed a really nice FSML proposal to install 2 new walk-up towers, including one in the hemlock section, also with potential instrument tramways. And there's a variety of remote sensing work that goes on here in the past, currently, and in the future that this plot data can really help in terms of validating some of the information that comes from it. Interesting sidebars, Andrew Richardson has a plan for the summer to use these unmanned aerial vehicles to get this really nice resolution, high-resolution imagery, and they're going to be planning on working on portions of the plot that can be used to estimate individual trees. And so that's one of the proposed activities this summer. And there will also be a NASA flight. I think it's a LiDAR-based product that will also take place at Harvard Forest this summer, which also includes other places here. And they never get the glory because they're always out in the field. And so I certainly want to thank especially the 3 diehards that were out all winter. They're actually standing in the back. They deserve a great bit of credit for doing that. I want to point out Stuart Davis was instrumental in getting this plot, you know, set up, established, and working and moving forward. Rick Hunt had helped a lot, especially in the woods crew. None of this could happen without the help of the woods crew that did so much of the groundwork to get this thing off, you know, started with all the posts and everything. And I've had 15 crew members too, so I hope to share more with you next year. And then,
how are we doing on time?
Good.
Couple minutes, all in. So I just wanted to bring people up to date on the hemlock removal experiment. I have 2 brief slides. We As Dave and David have talked about, we've been looking at different effects of the adelgid in an observational context throughout New England for more than 20 years now. And when I came here in 2001, I thought it would be a good thing to try and do some experimental work on this as well. And so we set up an experimental hemlock canopy manipulation at the Sims track. It took us a couple years to get it underway. It took us, Audrey, some time to actually find plots that we could use. And we took data for a couple of years, and then we applied 2 different treatments in one set of treatments. It's a block design. In one set of treatments, we logged out all the hemlock. We pretended we were loggers and took out hemlock and big trees to pay for the cut and to help build the barn, as I recall. And in the other manipulation, we girdled all the hemlock standing in place so that they would die more or less slowly as if they'd been attacked by the adelgid. And so in our original intention, and at the time the adelgid wasn't here yet, as it is now, and so the original design was to contrast what was going on in the hemlock stands, in intact hemlock stands, with what was going on when you physically removed hemlock from these stands, either by cutting it and dragging it away or by killing it standing in place. The expectation was that the adelgid would eventually get here, and our hemlock control would become a infested plot, and then we would move to the phase where we contrasted our physical damaged plots to one where the adelgid damaged the hemlock. And essentially that happened in 2010. So we've gone from a pre-treatment, post-treatment, pre-adelgid situation where we were really focused on comparing our control plots to our manipulation plots. Now we're in our post-treatment, post-adelgid universe where we're really comparing our infested plots with our girdle manipulation plots. At the same time, other things have, of course, happened in the system. The moose have become more abundant. We've split our plots. We've actually put moose exposures in all the plots so that we can look at additional additive and interactive effects due to moose. And so this is big experimental infrastructure. We have 8 hectares of forests that are manipulated, and lots of things have been done in them by people who say, oh wow, you have a bunch of canopy manipulation plots, what can I do? And so we have people working on everything from carbon to salamanders. The biggest challenge with any of these long-term experiments is when you write things up. And so we've actually taken this benchmark as our first write-up phase. And I just wanted to highlight some of the things that are out or coming out very soon about this. We had a handful of studies that focused on pre-treatment conditions, and we have a whole slug of papers that have come out in the last year or are soon either to come out or be submitted on this post-treatment pre-adelgid phase. And then I imagine we'll wait another decade before we write anything else. But a whole bunch of this is now out. This one on microclimate effects, I just did the galleys on this morning. So we're up to this line here for things that we can actually read, and we've got a few in reviews. So it's been a productive project, and we also have, in addition to moose and mammals, we have, or moose and large mammals, we have small mammal studies starting this summer too out there for people who like little furry things. But anyone who's interested in adding expertise to this, we still lack bird expertise, for example, and other things would be most welcome. So with that, I'll stop, and if there are any questions for any of the 3 of us, great. Otherwise, I assume it's getting close to tea time. Questions? Everyone wants a cookie. Okay, cookies.